Hi, physics. Mr. Janowski here. This is Chapter 8, Homework 1, Problem 4. So this is going to bring together some of the different ideas about momentum and some of the different equations. So what do we have going on here? We have a 2,200 kilogram car traveling at 26 meters per second, and it's going to come to a stop somehow. So in parts A, B, and C, they're all starting out the same, but they're all going to come to stop a different way. So what is the average force on the vehicle if it stops by? So let's do this. Step, huh? What is the average force? So we want the force. So for parts A, B, and C, I don't think I'll do all three of them because after we set up the first one, they're all the same. But we're looking for F. So F is question mark newtons. So that's what we're always going to look for. What is the force question mark newtons? So let's think of what's going on here. We've got a car traveling at 26 meters per second. So notice the question doesn't tell you. I'm going to call this step 1 because it is a sketch, but we're not really doing this, according to a particular strategy yet. It doesn't tell you if the car is going left or right. So either the car is going right. So let me draw two different sketches. So either the car is going to the right and it comes to a stop over here at the left. So no speed lines at the end. So we have mass is 2,200 kilograms, and V initial is 26 meters per second because it's going to the right, and V final is 0 meters per second. All right, so if we do it this way, let's start here. If this is what's happening, we're going to have a certain change in momentum. So we could figure out that P initial, I'll change colors for this. P initial is equal to M V initial, which is equal to 2,200 kilograms times 26 meters per second. So 2,200 times 26 is going to give us 57,200. So this is P initial. And the units will be kilograms meters per second. Now let's look at what's P final going to be? Well, that's going to be easy. So P final is equal to mass times V final, but V final is 0. Therefore, P final is equal to 0 kilograms meters per second. Okay, so we've got that. Now notice if we do it this way, delta P is equal to P final minus P initial. This is going to give us negative 57,200 kilograms meters per second. So you get a negative number here. You could do it this way. This would be perfectly fine. But instead, imagine what would happen if we did this the other way. So if instead the car starts off going left, goes, as far as it goes, and then stops somehow. So if we did it this way, V initial would be negative 26 meters per second. V final is still 0. Now, if you did it this way, notice you would have a negative P initial. I'm not going to do the math again, but P initial would end up being negative 57,200 kilograms meters per second. P final is still going to be 0. Kilograms meters per second. Okay. If you do it this way, delta P equal to P final minus P initial. Well, now we've got 0. Keep forgetting the dot. Kilograms meters per second minus, because we're subtracting a negative this time, 57,200 kilograms meters per second. Okay, if you do it this way, delta P ends up being a positive number. So there's two ways of looking at this. One way gives us a positive number. One way gives us a negative number. Which one is right? Well, neither one is more right or wrong than the other because I didn't tell you if the car was going left or right. You can pick either one. Personally, I'd rather use the positive number. So just use that one. So now we know what delta P is. Okay. If we know delta P and we're trying to figure out F, remember step, huh? And we know the time, how can we do that? Okay. Well, we know that, first of all, yeah. So ignore this one. This is the one we're going with. Okay. So if we know that, how can we do this? Well, we know that J is equal to delta P, and they have hats. We also know that J is equal to F times T. Okay, therefore, take those two ideas together, you're going to end up with F times T is equal to delta P, and therefore F is equal to delta P over T. And remember what's going on here. In all three cases, we have the same delta P. The thing that's just going to keep changing for us is the time. So let's just do part A. Delta P, again, for each one, I'm going this way, 57,200 kilograms meters per second. And what is T for part one? It's 21 seconds. So if you do that, 57,200 divided by 21, the calculator gives you a number, 23.809,524. And the units for this would be newtons because this is a force. Okay, so here's our number. The thing is, you notice that number looks a little bit different than our answer, which is just 2,700 newtons. It's a sig figs thing. So the numbers that we had here, I mean, technically I shouldn't have even written this with 3 digits because with 3 sig figs, because the numbers that went into it only had 2. So that one only had 2. This one only had 2. So technically, the most correct way to write your final answer should really be, and you know what, I'm ignoring the hats. We're really just talking magnitude here. It should really be this. So yeah, just sig figs and those annoying little rules. Yeah, we didn't know the mass of the car with greater precision than 2 sig figs. We didn't know the velocity of the car with greater than 2 sig figs of precision. So we can't claim more than 2 in our answer. Now, if you wrote on your test 2,720, that would be fine. Newtons, you'd have to have the units. If you wrote 2,724, because the 8 should make you round up, newtons, that would be fine too. I'm really not a stickler on the sig figs, the way that I probably should be, but again, I find those rules annoying, so I'm not a stickler. Anyhow, I'm blabbering at this point. So that's how you do this problem. Parts B and C would be the same. The only thing that's going to be different is you're going to keep changing the time, and you'll keep getting different forces. So hopefully you found this helpful.